meron 포기하고 싶은 꿈 Until the end of time 지금 난 간절히 원해.
Hello everyone, good day. For this project, I will be performing a time series analysis using the ARIMA model. The dataset that I use represent is monthly electricity consumption data, which I prepared on my own and was not provided by the professor. Then, the main objective of this project is to analyze historical electricity consumptions patterns and forecast future consumptions using the ARIMA model. So, go na tayo. Then, ang gagawin natin is first, open the Anaconda app. Then, launch the Jupyter. Wait na lang natin. Natin is mag-ano tayo na pilitin natin itong new folder. Then, pilitin natin siya. Ang gagawin natin is mag-upload tayo. Upload na natin yung monthly ka. So, ayun na siya. Pag ano natin, ayun na siya. Then, new ulit. Dito na tayo sa 5 time. First, gagawin natin is mag-install tayo. So, the script install. So, tutunod tayo sa home na new magpa-Python na ulit tayo. Magpa-code na tayo naman. So, yan. So, ayan. Na-type na natin yung code. First, so, ayan. First, I loaded my CSV file using the pandas library in Python. Next, I converted the month column into a date time format and set it as the index of the data sets. This step is very important because time series data must have a time-based index in order for ARIMA to work properly. Then, next naman is, so next na ulit tayo for data visualization naman. So, ayan. After preparing the data, I plotted the time series to visually inspect its behavior. Based on the graph, you can observe there is an overall trend in electricity consumptions. Then, there are seasonal patterns with higher consumption during the mid-year months. These observations suggest that the data is not stationary, which means further processing is required for applying ARIMA. So next step is for stationary check. So check na natin, ABF test. So, tinype ko na yung code at yung lumabas. So, before fitting an ARIMA model, it is necessary to check whether the time series is stationary. A stationary time series has a constant mean and variance over time. To test stationary, I use the augmented Dickey-Fuller or ADF test. Based on the result, the p-value is greater than 0.5, which means we fail to reject the null hypothesis. Therefore, the original electricity consumption data is non-stationary. So, next step is differencing the data. Edit na to. Talaga? Hindi ko nakain. Kasalita ko, nakakainit kayo. Dito pa! Nakakainis to. Natapos na eh. So, ayun na yung lumabas pagkatapos natin tinype yung code. Since the data is not stationary, I applied first order differencing to remove the trend and stabilize the mean. After differencing, the time series fluctuates around a constant mean, which indicates that the data has now become stationary. This confirms that the d-parameter This confirms that the t-parameter of the ARIMA model is equal to 1. Next step is fitting the ARIMA model. Let's type the code. Normal lang lumabas siya. Then, type na natin yung code. lumabas na yung sa Remax results. So, once the data became stationary, I fitted an ARIMA 111 model to the dataset in this model. P equals 1 represents the autoregressive component. For D naman, equals 1 represents the differencing order. Q equals 1 represents the moving average component. This combination allows the model to effectively capture the structure of the time series. Then next is for forecasting naman. Let's start. So, ayan. Ito na yung lumabas na result. After fitting the ARIMA model, I used it to forecast electricity consumption for the next 12 months. The forecast provides an estimate of future electricity demand based on historical patterns and trends observed in the data. So, ayun na. In conclusion, the ARIMA model was successfully applied to model and forecast monthly electricity consumption. This project demonstrates how time series analysis using ARIMA can be applied to real-world datasets to understand trends and generate future predictions. Thank you. Mas di pala naka-play. Tapos di pala naka-play, no?
Pero pogi하고 싶은 봄 싶어